Hi, I wanted to show you the output of this dual Colpitts oscillator thing. This is the circuit down here. It's being fed by 13.8 volts and about 300 milliamps. So I've got the output going through this combiner thing, which is mixing the two signals together, and that's going up to my lower bandwidth scope that I've got up here. Now, what's going on here is that where this thing is at maximum amplitude is when the two frequencies, so we've got an output at 10 megahertz, we've got another output at 10.24 megahertz. So when the two are mixing together, so when they're in phase with each other, that's when we get the maximum amplitude here. And then when they're exactly 180 degrees out of phase with each other, then they're going to cancel each other out, which is why we're getting this lull here. So that's why this pattern looks like it does. It's quite an interesting picture on the scope. But if you think about the two different frequencies going at different rates, then they are at some point going to be in phase with each other, and at another point in time they're going to be out of phase with each other, which is why this looks as it does. You can see the same thing on this scope that I've got here. It's exactly the same display. But the reason I use this top one has got a 50 ohm output panel on the bottom of it, which gives a fixed 50 ohm signal out from the back of the scope, and that feeds down to my spectrum analyzer, which is down here. So what we can see here, this center point here, this center tuning point here, this is 10 megahertz, and this is currently set to 100 kilohertz per centimeter. So we are, did I say 100 kilohertz? It's 0.1 of a megahertz, it should be the right answer. So this is 10.1 to 10.24 megahertz is what we've got here. So you can see that it's fairly clean signal. There's not a lot else. There's a couple of spurs either side of that, a couple of spurs either side of that, but they're well down in the noise. So this is 10, 20, 30, 40 something dB down, and some tiny little bits and bobs along the bottom. But that's an extremely clean two frequency signal that this oscillator is generating. So for the purposes of IMD distortion measurements in receivers, which is why we've built it, it's looking pretty damn perfect to me.